recording and system context modeling, share. Okay, so now we're getting finally to the interesting aspects of the course, our first modeling lecture. Now, the whole point about system context modeling is that we're going to be creating a class diagram. I know you don't know what a class diagram is just yet. You will be creating class diagrams when you get towards the latter end of your lab, and we'll be depending on it quite heavily when we get to the software design course. Now, the concept of a lab, let me just close the blinds. The concept of a class, you should already know that though from SE 120 and maybe even at the end of SE 100, I'm not sure. Okay, but a concept of a class, what is a class? Okay, basically a class is a concept. All right, it's not an instance. Matter of fact, we create instances from the class. Okay, and the way we draw a class is we draw it as a box. All right, for example, when I look at everybody here in the classroom and guys at home as well, all right, I'm seeing instances of the concept of a student, right? So this is the concept, and it's sometimes even irrelevant from the instance itself, because I here play the class of professor. But if you and I were both to go to a restaurant, then both of us are playing the class of a customer at this point, okay? Now, in a system context model, we will represent the system itself as a class, as a single class. Can you imagine this, right? As we just created one class representing the system. That's obviously not giving us a detailed view of what's going on inside the class. And that's fine, because that's not the point of system context modeling to begin with, okay? The other thing we're going to do is we're going to represent all the external entities that deal with the system also as classes as well, okay? Could be users, other systems, devices, right? Input devices, input, output devices, all right? We call those later on, and when we get to the use case modeling chapter, we'd like to call those actors, okay? All right, so here's how it goes. Let me step out of here for a second and just open up the, no, I don't have it ready yet. Okay, let me just step out here. Okay. Where's the Microsoft screen? There we go. Just do that class. All right, so here we are. So again, let me just emphasize this, okay? We're going to be building our system, okay, as a class, and every box that you see is a class. And then outside is what we call the system context, okay? Now, the context differs, okay? If I'm gonna build a system to be deployed at an airport, it's different than a system that's gonna be deployed at a university, then it's gonna be if it's deployed at the desert, okay? It's the environment, the context that they're in, okay? So this pink area that I've just drawn, this is what I like to call the context, okay? Sometimes you hear that politicians or celebrities they say, oh, they've taken my comment out of context, okay? So think of the red box as the comment, and it means something good if it's within the proper pink context. But now if you take that same comment and you put it in a different context, then suddenly it's a bad thing. For example, the comment could be, I like this. Good, all right? And then the context could be ice cream, okay, or different ice cream flavors, all right? So that's definitely not good, all right? Now, if I take that same comment, which said, I like this, and I put it in a different context, okay, maybe something really, really bad. Now it seems like that person is saying, I like that thing that is really, really bad, all right? So what we're starting off with, believe it or not, and as the first thing that we're gonna get to do when we get to create a system, what do we start off with? It's what you're actually seeing on the screen right now. Just, yeah, it's got a white screen. You got nothing. Okay. What we know is that I'm going to have a system in the end. Okay. Okay. But now what I was saying a moment ago is that right now, I don't really care about what's going on in the system, because what's going to be going on inside the system is affected by what I'm going to have outside the system. All right. What I'm going to be have, in other words, my context. All right. Because simply put, systems are created to serve us. We don't create systems so that we serve it. Okay. In other words, if this is us, all right, and we have our needs, well, then better to have that system actually adhere and realize our needs. تلبي طلباتنا, all right? If that system is not doing that, matter of fact, we're the ones who are servicing it, then why the heck do we have it in the first place? All right. So it's natural that we begin from the outside in. Okay. Now, obviously, I've taken a bit of an extreme example saying, well, a system would have been different from if it was at the desert, or was at the hospital, or was at a university, or was at the airport. Of course, you're not going to be that way off, creating a system for a hospital, realize at the end that it was actually deployed at a university. But within a hospital, I might have different people who are going to be using that system. Okay, so I have this person over here. We got the doctors. Okay, a class of users. Okay, and we also got nurses. All right, and each one of those have their own user needs. Well, yeah, they're the class, of course, of users, but they have their own user needs. The functionality is exactly the functional requirements. Okay, so the doctor says, I'm going to call this D1, they got D2, they got D3. All right, nurses says, I got N1, I got N2, I need N3, and so on. All right, so I notice these, I realize them, and I start to say, طيب, inside my system, let me start to create the code that satisfies D1, D2, D3, N1, N2, and N3. Okay, with the different classes, the different functions, the different whatever it is that you have to do inside to make those functionalities, those functional requirements become a reality. Okay, fine. This looks like a very reasonable system for a hospital, right? Now, one thing we might have completely missed out is recognize that a patient could also be a user of that system. Now, if we didn't even pick up on the fact that a patient even exists in our context, then obviously it's not about this. It's not that the system doesn't work. It's just this list over here of requirements that I'm going to later on create code for, where I'm never even going to think of it, because I've never even considered the patient as part of my context to begin with. Right. So we have a doctor, we have nurses, they have their own. So the doctor wants to say, I want to be able to check on my patient such and such, all right? And nurses would like to say, like, I need functionality that creates reminders so that I can give the certain doses to the patient and so on, right? Now I'm going to create code to do that. I'm going to create code to get the system to do that, to show, for example, data reports to the doctor, to show reminders to the nurses. All right. Now, a patient, one of the things that a patient wants, for example, is to be able to book an appointment. This is a very logical need that pertains to the patient. Doesn't pertain to nurses. They don't want to book appointments, and definitely doctors are not going to be booking appointments. Okay, unless they're playing the role of the patient at some point, right? But the point is here, if had I not even realized that my patient as an actor, as an external entity, even exists in my context, then definitely P1, P2, and P3, I wouldn't even have considered those to begin with. So a whole class, a whole list of function requirements that I should have and I would have created had I noticed my context, that the patient's part of my context, then I would have been missing that. All right. So when we actually go into a new area, a new domain, all right, And again, what we're doing is, let me draw this again. Again, we know this is my system. All right. And I'm trying to figure out what's actually going to be in my context. So I actually go to a university and I observe. We do ethnography. Remember, we did ethnography? Okay, so I went to the university. I'm going to go check out what's actually inside the university. All right. I realize there is students, there's professors, there's a concept called a registrar, okay, student affairs, okay, there's accounting, all right, there's this, there's that, right? Different concepts that I would have and different entities that we'll be dealing with, okay? So first, I figure out the entity that I'm going to be dealing with, and then with it, I start to dig down to say, what is it that this entity, external entity, like the doctor, wants from us? So I know we're going to be interacting with the doctor, but what does the doctor want from our system? And this is where I say D1, D2, D3, D4, D5. When we do the D1, D2, D3, this is where we get to use case modeling. That's the topic for next chapter. Okay, but in this chapter, we're just trying to figure out that this guy even exists to begin with. Okay, and it's hard enough. Okay, remember what we're starting off with is white space. Beyond the box in the middle, I have nothing else. And so it's hard enough of a job to understand and to identify the external entities that exist in my context before I move on. Okay, and we will be doing some exercises, hopefully at least one of them today, okay, where we have to see how easy or not so easy this is, because when I go through the slides, it's gonna look super simple, but when you get to do the actual exercises, suddenly it's not so simple. All right, so let me go back again here to the slides. Okay, so I have my system context modeling. Okay, we're going to show the operational context. Okay, and at this point we don't care about what's inside, we just treat it as a black box. Okay, another reason why we don't care about what's inside, because we want to use all of our focus on trying to realize what's on the outside. Okay, it makes a difference if system X was used in a classroom, hospital, airport. This is what I was saying a moment ago. First step towards identifying what our system will interact with is who are we interacting with, and then why we are interacting with them, so that we can figure out what is it that they want from us. We develop the system context model as a simple architectural model, basically a block model. You can think of it this way, but these blocks are really our actual classes. Think of it as classes. Although those classes, a system context class diagram in itself is not going to turn into code at any point, but it helps us for understanding. I mean, we can use a class diagram as a tool for us, okay? And thinking of things as classes helps us. We don't have to turn it into code at the end, okay? It doesn't have to be like the classes that we create as we're doing our program, okay? So in this particular context of an ATM system, we have the ATM system in the middle, and then we realize what are the things that we're going to be dealing with. We're going to be dealing with databases. We're going to be dealing with certain maintenance system, a security system, a branch accounting system. Okay, all of those I'm going to be dealing with at some point. Now, some of those I'm going to be dealing with because they want something from me, and some of them the system, will be dealing with them because I want something from them. Okay, now how does that mean? Okay, we said a moment ago that we create system to serve us, not that we serve them. Okay, but in reality, what happens that sometimes in order for me to serve person A, I need to talk to person B. Okay, so for example, a customer is trying to buy a book from an e-commerce system like Amazon or whatever, right? So Amazon is our system. So they say, I want to buy that book. I want to buy it through a credit card, maybe Visa, MasterCard. Now, there is an authentication system for these credit cards. Amazon will be rather silly to create those systems themselves. They already exist with MasterCard and Visa. So Amazon will then reach out to MasterCard and Visa. And now Amazon is the client, reaching out to MasterCard and Visa system saying, here's the numbers, here's the CVV, here's the expiration date, is this a valid credit card or not? And then go ahead to get either yes or no, this is a valid credit card or not, and then the transaction gets performed. Okay. Now we like to call the credit card and the Visa system as secondary actors. Yes. Yeah. Of course, they have to benefit. I mean, think of it this way. This is the reason why all companies work with, say, Visa and MasterCard, because even before the internet, it's because if a company says, I'm not gonna buy it, I mean, we're way off the topic of the lecture, but anyway, if a company just says, I'm not gonna deal with MasterCard or Visa or anything like that, well, then you're gonna lose a whole lot of customers who like to buy with the convenience of credit cards and not cash up front. Okay. Now, actually, what happens is that the store that you go to, okay, they pay money to MasterCard and Visa every time. Yeah, exactly. So this thing is worth, that coffee you have is worth, I don't know, 10 reals. Okay. Then Starbucks actually pays 1 real out of that 10. Had you paid cash, they would have taken all the 10 reals. If you pay in with credit card, they take from you 10 reals, but they give 1 real to Visa. And this is where the real money of Visa comes in. Obviously, the other aspect of Visa is that if you fall behind on your payments, and there's an interest, and you have to pay a lot of money for that. Okay. Um, those who just use the card and they pay it up front at the end of the month, Visa is not really actually making any money. Matter of fact, probably the customer is actually making the money at this point. All right. But yeah, obviously there's a financial benefit going both ways. All right. So yes, so Starbucks will give 1 real out of the 10 to Visa. Obviously, it's not as big as 1 real, it's 10%. But at the same time, had MasterCard said, La khas, we're gonna deal with cash only, well, then their sales are gonna drop by 95% probably. All right. All right, so some mistakes. Okay, first mistake is here at the top. Let me just use the laser pointer. Uh, we don't show subsystems. Okay, we just show the outside box of a system. We don't show subsystems. So we got to, even for the something external that's dealing with us. Okay, we don't care about its subsystems. All right, this is not the place for it yet. When we get to the detailed design and the architectural design, it's a completely different course. We'll deal with that. We'll figure out the subsystem at this point. Okay. Remember, at this stage, we're trying to figure out what the problem is. Okay. I'm going to re-emphasize this aspect of having a hard time just figuring out what the problem is, and also in the next chapter as well when we deal with use case modeling. Okay. One other class, very common class of inputs are those generic inputs, okay, like a keyboard and a mouse. Now, we don't tend to show keyboard and the mouse because what we really want to show is the source of the information. It's the source of the information, okay, which really these are generic input devices, and their source is the human being who's standing behind them. So I'd rather show the human being or the class of that human being being a doctor or nurse, rather than just saying a mouse and a keyboard. That's not really telling me so much. All right. So it's the source that I sort of like care about the most. Now, again, we have to be careful about this. Okay. Because if this device is not a generic device, but it's actually, it gives me right what we call business specific information. All right, business specific information. Then at this point, I'd rather actually deal with the device, because I'm going to be creating certain hardware or certain code that deals specifically with that type of hardware. Okay. This is when it comes to input. When it comes to output, is a little bit different. Okay. When it comes to input, there might be two layers. Okay. For example, the sun heating up the heat sensor. The heat sensor is giving me information. At this point, I care about the heat sensor because I'm reading analog information from the heat sensor, not necessarily from the sun. Okay. Now, when it comes to the output, okay, one would look at, say, a screen as a generic output, or a printer as a generic output. Now, if the output really was generic, I would actually, for example, put down saying, I'm outputting this to an operator, I'm outputting this to a doctor. But if the output again is in itself rather business specific, for example, a special type of printer or a special type of screen, all right, then in this case, I want to put down the business specific instrument that I'm dealing with so that I know when I get to design the code for it that I'm actually dealing with that sort of hardware. All right. It's a bit of a, I'm going to tell you right now, it's a bit of a gray area. It's not black and white. And we'll get to that when we do the exercises in a moment. Now, one common mistake is calling the system, okay? That doesn't tell me much, okay? Just like calling a class, the class, right? So much goes into the name of something, okay? We tend to use the names as abstractions to help us reduce the cognitive load. Exactly. So if I just gave you a class called the class, what do you have to do to understand what's going on in that class? You have to read it line by line. If I give you a class called student.java, khalas, you know that this, what's inside, I don't even need to read a single line. It's going to be the attributes of the students. It's going to be the operations, i.e. the functions that the students will do. Okay. So if it's a system, it's not an exception. Give me the name of the system. So I'm dealing with a reservation, ticket reservation system. Give it a name. All right. When I give it a name, it helps me also with my scope. All right. I know what this system is going to do and what is not going to do. Okay. The problem with the scope is if we get it wrong, we might do one or two things. Both are just as bad. A, we might be doing something that's already happening elsewhere, like the credit card validation part. Okay. Or we might forget about a big part of our functionality that we're supposed to have been completing. Okay. Now, if this is my system, all right, what I deal about is my first degree family, i.e. the ones that I have direct contact with. Okay, so if this is my system, I care about its interaction with, say, external system 1. I care about the interaction with external system 2. I don't care about the interaction with between external system 2 and 3, and maybe even 4, 5, 6, 7. The whole world is interconnected. I'm not going to be dealing with all of this. I only care about the ones that I'm going to be touching immediately. Okay, those are the ones that I care about. Even if the ones that I'm touching immediately themselves are touching each other and there's an interaction between them, I don't really care about those interactions. I don't even care about modeling them because they mean nothing to me. You wouldn't model the interaction? Between them, no, I don't care about them. Okay, it's just it's my interaction with them. All right, what they deal with each other, that's none of my business. Okay. Exactly. Exactly. So I only deal with them. All right. Now, the point is, all right, um, you know, you have a customer, they go to Starbucks, okay? But the way you went to Starbucks is that you took Uber and then you went to Starbucks, okay? From Starbucks perspective, your relationship with Uber means absolutely nothing to them. You came here through Uber, you came here through a family member drove you, you drove yourself, you flew in from the sky. From their perspective, they don't really care. Okay, so your relationship with the transport system is absolutely meaningless. Okay. All right, so another thing is that another mistake is that our system, the middle one, is a thing. And if it's a thing, it's a noun. For example, the weather reporting system, it's a noun, okay? It's not something to do. To do means a verb, okay? So if I write down something like a verb, like a system as a verb, it could be retrieve weather report. That's a function. Matter of fact, we'll say that's a use case, right? Get name or whatever, make a phone call. That's not the system. That's what the system does, okay? Now, I might figure out from retrieve weather report that this is a weather reporting system, but this is a guessing game, right? So I might get it, I might not. Do we want to play that guessing game? No. Okay. Not when there's millions of reals on the line. Okay, so getting and retrieving and modeling of the retrieval and the functions that will be done in the next lecture, which is about use case modeling. Now, that doesn't mean that this lecture is over, it's far from it, okay? We're not leaving system constant context modeling just yet. Now, guys at home, and even you guys here, there is some exercises that's already up on Moodle. You have it, okay? Guys at home, okay, so I want you to go to Moodle. You'll see under a page called system, so in-class exercises, a module called in-class exercises, and you'll see 3 files there. These are the same 3 files that I have in my hand right now. Okay, we'll do 3 exercises. Actually, we'll do 2 out of the 3. Now, the way it's gonna go, okay, we will do 2 in class. You'll do 1 by yourself at home, all right? And send me the answer. Now, I'm not gonna be running after you to do the one that at home, okay? It's for your benefit, okay? But if you solve it and you give me the answer, I'll give you feedback saying you did well or you did not do well, okay? So think of it as an ungraded exercise or ungraded homework, okay? Then exercise number 4 will be in your quiz. Exercise number 5 will be in your midterm, okay? So you've gone through 4 different exercises before we get to, all right? So the first one we're going to be doing is called the aquarium system, okay? It's going to be an aquarium system, all right? Before coronavirus, I used to have a student that come up here, and for every exercise, I get a different student to actually do the exercise with the other students while I observe. But because of coronavirus and all this, and because most of you are actually at home, then I'll be handling the pen myself, okay? Hopefully this would change rather when we get to next semester when I'm teaching you software design. All right, so guys at home, did you pull out the exercise about the aquarium? Are you ready? Anybody still needs some time? Just type, just saying, give me a moment. Okay, so let me switch now to the white screen. Where is it? There we go.
Doctor,
Yes.
which one do we open?
The aquarium system is called aquarium. I'm not sure what's it called file, but the word aquarium appears. Aquarium context modeling, yes. All right, so all right, so I'll get you guys to hopefully get the guys at home to be involved with me as well. Okay, so what I'm gonna do is I'm gonna read this exercise line by line. Now, if you're at home, it's better that you pull out that exercise on your phone so that or get a notepad, because what you want to do is what you're drawing on is different from what you're viewing the exercise on, because it's difficult to do both and switching back and forth between the screens. All right, type. Here we go. So the city of Riyadh has recently approved the construction of a state-of-the-art aquarium. Okay, I'm going to stop here. All right. Do we have enough information? And what can we write? I know I'm going to have a system in the middle. Do I have any idea? Aquarium? Okay, is that what it is? So what's your name? Aisa. Yes, I asked you that last time. Okay. So Aisa, it says aquarium. Okay. Now let me tell you a little thing about these in-class exercises. Okay. Now, when somebody says something, right, I encourage that. I really do encourage that. All right. But for the others who are not being involved, what I'm going to do is if you don't say something, then I'm going to assume that you agree with what that person just said. All right. So then I'm going to ask you saying, do you agree with what was just said? Okay. If yes, tell me why. And no, tell me not. So it's better to be engaged and get it wrong. For me, that's absolutely fine than not to be engaged at all. Okay. So we got aquarium type. So the system is the aquarium, okay? Remember the system, yeah, Isa, it's something. No, it's not about this, as we're gonna get to the more. It is what is gonna turn into code at the end, okay? So let me that be to a hint of what I'm trying to get to in a moment. Okay, so that's gonna turn into code. The aquarium, the system is the aquarium, gonna turn the aquarium into code. All right. Are we seeing how we're already going off the rail here? But that's fine. That's absolutely fine. We'll just wait for a moment here. Okay. Type. The aquarium features many facilities, including the main attraction, which is the fish tank. All right. Now, I want an answer from somebody who's at home. Okay. So, guys at home, tell me what to do. If I don't get any answers, I'm going to ask somebody specifically by name. Okay, so it says the aquarium features many facilities, including the main attraction, which is the main fish tank. The monitoring system of, all right, so I think we should add a box for the fish tank. Okay, so that's my fish tank. I like that. I like those ideas. Fish tank. Like that, yeah, Faisal? Because it needs a system for itself. Okay. So I like the first one, but the second one is weird because now you're saying like we're creating two systems. We're not creating two systems. We're creating just the one system. Okay. So which one is the system? Is it the fish tank or is it the aquarium or is it neither? Guys in the classroom. So far you're saying neither. Okay. And the answer is it is actually neither. Okay. It's actually somebody already said a moment ago. It is the monitoring system of the aquarium. Yes. Right. I think who was it that said that? Dalal. All right. So I'm going to delete this whole thing for now. And I'm just going to say state of the art monitoring system. Okay. I don't like to read the word system because if I don't read the word system, then that's usually a red flag for me. Okay. Type. Next up, the fish tank will be equipped with a state-of-the-art monitoring system, which cares for the fish after the fish. Okay. So obviously, that actually puts it all together. That what we're actually developing is the monitoring system. It's the software that's going to help us with monitoring. It's not the aquarium itself. Not going to, and it's not the fish. We're not going to turn the fish into code. We're not going to turn the big tank into code. We're turning the system into code. But what is the system itself? Right? So figuring out what is the system, the middle box in itself now, that was an exercise on its own. That we're doing the monitoring of, oh, no. We're doing the monitoring, where is it? Where did I go? There we go, sorry. Of the fish tank. Type. The tank is equipped with a food weight scale. On what basis did we choose the system? Type. So Ryan, so again, I'm not sure if I already answered your question or did you just ask that right now? So the system must be something that could be code. Yes, exactly, Afad. Okay. So the system is gonna be what's gonna turn into code. Okay. Gotta think of it this way, right? If it's not something that's gonna turn into code, it's not really our system. Oops. All right. It has to be codable. Exactly, Arayan. Exactly, right? We have to think of it this way, right? If you think of a human being, we're not going to turn the human being to code, okay? Fine. So it says the tank is equipped with a food weight scale that measures the weight of the available food in the tank. All right, so that's the box. But what's inside the box? Guys at home, tell me, is it, and guys here at home as well, let me ask you that question. Is it the weight scale? Well, is it the food? It's not a system, man. It's not like it's, I mean, yeah, it's a scale. Yeah, so weight, scale. Yeah, very good. Type, very good. A timer periodically triggers the system to check the weight of food and and based on the available food, the system sends a request to a food dispenser to dispense the appropriate amount of food. What do we do with this? Another box? Well, no, not yet. Are we dealing with the same box? So with that box, I got the weight scale. Now, is the weight scale it itself gonna dispense the food? No, it's something else. All right? It's something else. And what is that something else? Exactly. No, it's not. It's dispenser is a thing. Okay. Okay. So dispense food, that's a verb. Okay. I wrote this wrong. So food dispenser. Okay. Is it the food dispenser or is it the food itself? Khalas, you should be now aware of it that you're not going to be falling for this trick. Now, okay. Now, one thing it says here is something about a timer. Okay. And I think somebody was saying something about a timer here, one of the students here, but I can't remember who it was. Fahd. Okay. So Fahd is basically saying that the timer is a box. Should it be a box? Well, should it not be a box? Yes.
I don't think it should be a box because the timer is connected to the scale. The timer like triggers the scale at a specific point.
Is it triggering the scale or is it triggering my system to ask the scale? All right, it's asking my now, is a timer in itself as a concept? I mean, right? Is it? Yeah. It is. And I'll tell you why. Our software actually receives input from a timer, a physical input. That input is nothing more than a little signal, a little nudge saying, wake up, wake up, wake up. Okay? That's all the timer does. Now, just to give you an idea of what software really is, software is actually nothing but text. Okay? In fact, open any Java file that you've created in SE120 and open it through Notepad, you can see the same exact thing. Now, can that text magically figure out that every 2 seconds I gotta go wake up the weight dispenser? No. I have to have something else outside physical telling my code through the operating system, telling this code, this text, to actually go ask the timer for a reading. All right. It happens quite often in a lot of operations. Okay. Everything that is real time, that is based on timing, right? The timer doesn't actually deal with the physical device itself. It tells the software, and then the software is the one that, yeah, because sometimes the operation requires that the software gets input from multiple places in order to figure out what we're going to do next. Okay. And sometimes, like in this case, what I'm going to be outputting to is completely different from what I went and I polled. Polled means with an O, P-O-L-L means I go get information from, in this case, the weight scale. Okay, it's not P-U-L-L, P-O-L-L. Okay, so a timer is definitely part of the system. It's a piece of hardware, very small. The reason a lot of times we don't think of timers as an external entity because it's embedded in any piece of hardware that we have. So the phone that you have in your hand, it has a timer. The laptop that I have in front of you, it has a timer instead. Now, because we don't plug it in with a USB from the side, so we think khalas is part of the software, but it's not. Okay, it's a piece of hardware, all right, that connects with the software that I have inside. Okay, so the system sends a request to dispense appropriate amount of food. The system also has a light sensor and a thermostat. Light sensor and a thermostat. Both should be boxes, yes. So what's in the first box? Can somebody let me know? Light sensor. Second one is the, oops. Second one is thermostat. All right. If the external light from the sun in the tank is low, the system sends a signal to the lights in the tank. What do we do? I know I have the sun, it's over here. In what case should we put two things in a box? Normally, we don't want to put too many things in a box, okay? So unless that box is autonomous, that you really cannot split it, all right, then it shouldn't be in a box. Now, I think the reason you're asking this question is because you want to put the light sensor with the light itself. That's actually not the case. They're not the same thing, all right? A light sensor is different than the actual lights. Lights don't give us any input. They just take the output, go turn on or go turn off. The light sensor at the other side doesn't actually receive any input from us. Okay, it's the one that gives us the input, how much light there exists. So they're completely two different devices. Obviously, when you go drive down the road and you see the street lamps in the middle, both devices are embedded on the same physical thing. One gets the light, and then the other one is the actual light bulb, which one turns on. And this is why you always see Salat al-Maghrib exactly, then the lights do turn on, because the moment that it dims beyond a certain point, then the lights turn on automatically. So what am I missing now? It says the system also has if the external light from the sun. So I should put here the sun, huh? No, what? Why? Okay, good, good. All right. And then the light should be, or the light should be a physical thing by itself. طيب. The thermostat, on the other hand, what does it do?
No, I don't think light should be a separate thing.
No, this one, again, like I was saying, it's a completely different device that gives us input,
Yeah.
and we're given output to this one.
Okay.
Okay. We're relaying. Yes.
But do we put a box for the output?
Yeah. Right. Because, if I didn't put that box, then the person who gets to create the code for my system would have no idea what to do with that input that they just received. Okay. Best case scenario, they come back and ask, what am I supposed to do with this? Okay. Worst case scenario, you say, khalas, and there's nothing to output to, then there's nothing to output to. And then we're missing something of our functionality. And then it's just a light sensor, just keep feeding us information that we're doing absolutely nothing with it. All right. Okay. Similarly, if the thermostat shows the water temperature in the tank is low, the system sends a signal to a heater to turn on. A box for the heater. Yes, exactly. You're ahead of me, Faisal. Okay. All right, so it's pretty obvious at this point. Now, once the temperature reaches the desired level, system sends a signal to the heaters to turn off. What do I do with this statement?
Well, we have the thermostat.
We have the thermostat, we have the heater. Now, I read a different line. It says, once the temperature reaches a desired level, the system sends a signal to the heaters to turn off. Should I put a box here saying turn off?
I don't think so.
Okay, no, okay. Turn off is a signal, okay? It's what actually flies over here. It itself is not the thing that we're interacting with. So very good, you didn't fall for that. Okay, so what do I do with this line, guys at home? Okay, I'm gonna read it for the last time. It says, once the temperature reaches the desired level, the system sends a signal to the heaters to turn off. Exactly, nothing, all right? Now, the person who writes this document, they're not working for us, okay? It might be whatever we were able to retrieve during our interviews, our ethnography, our questionnaires, right? Not everything that's gonna be written there is because, all right, because they know that you're gonna be doing the system context, so they have to write everything carefully so that they don't really offend you or upset you or anything. They're gonna give you, and you have to deal with whatever it is that they're gonna give it to you. Okay. The system also allows the tank operator to manually perform any of the above mentioned tasks.
An actor.
Okay, so that's an actor. Right now in system context modeling, even the actors are shown as a class, so there's a box as well. What do we do with that statement? The system also allows the tank operator is a human being, by the way, to manually perform any of these things Yeah. Well, an actor is a box, so it's gonna be a box. But what's inside the box?
The operator.
The operator. Okay. So somebody said operator, and then somebody says interface. Okay. Which one is correct? Okay, guys at home, who do you think overriding switch? Well, not. I mean, it was an overriding switch, but through obviously some sort of an interface. So, what do you guys think? Is it the operator, or is it the interface that I should be having? I'm not going to be having both, of course. One is right, one is not right.
The operator, we keep operating.
Okay, can I get votes?
Operator.
Operator,
Yeah, they're doing it for both.
are they saying what? The interface, since we, okay, interface,
Because operator
okay.
cannot be coded.
Interface doesn't tell what it is, huh? Say what?
The interface could be coded, but the operator.
Yeah, but what could be coded is what we care about in the middle.
Interface.
Okay. Outside, we don't care about what gets coded, what doesn't get coded. Sure, we're using an interface. The word interface means nothing but something that we sit outside that allows us to provide input. Okay. So the screen that you have on your phone is an interface. It's an interface between what's inside of the phone, the phone, and you outside. And it gives you output and you put in input. But it itself is not any of the source of any of the information. Okay. So the word interface to me, all right, obviously the operator will be dealing with the interface to put the system. But if I put the word interface, even if I said the control interface, I'm missing the point here. Okay, because the control interface at this point is a very generic thing to say. Okay, it's not a very business specific thing to do. Okay, yeah. If you stand at the ATM machine, here's another example, and you see there's buttons on the side, 4 on the left, 4 on the right. Okay, the button itself, in this case, is nothing but a generic input device because, and I'll give you the proof, every screen you go through, the button has a different function. Okay, one time you were using that button to say I want to withdraw cash, not deposit. The other screen you were using it to say I wanted 200 riyals, not 300 riyals. Okay, so that the source of all of this is actually the customer standing in front of. So we don't really care about the button. We're missing the point. Okay, what we're actually getting is the desires of the operator. Okay, now here's another different type of button. Okay, you've probably seen like in the Hollywood movies, and you see like one of these fighter jets. Okay, and then there's a red button for firing a missile. Okay, that button has one purpose and one purpose only. Okay, so that's a very, very specific. So I could have at this point said the missile firing button. Okay, because very, very specific. It has a very specific has a very business specific function to do. Okay, another button is the eject button where it shoots the pilots in case the plane is crashing. Okay, again, that's a very, very specific button for us to do. But with keyboards and mouse and even the buttons that you see on the side of an ATM machine, they're not really specific. The screens that you see in front of you, they show anything that you want it to show. Okay, it's not really a business specific thing to do. Okay, so the proper answer here would be that the proper device or the class that I'm putting outside is the actual operator, not
Like a student operating the university.
exactly operating your screen through your screen to deal with the registration system. It's not the screen that's actually registering in the courses. It's you, the student, who's actually writing this course. And if I put down, I mean, think of it as a positive and negative. If I put down screen and I leave you out, and I give that horrible design to my design team, I'm not really helping them that much. I'm telling them that screens want to register courses and drop in courses, which is really silly at this point. Okay. One last line. The system also prints various reports using a designated printer. Okay. So what should I have over here? I completely messed this up. Oh, no. So what should I have over here, guys? Can I say operators buttons
report printer.
Controllers. I'm not sure I understand the question, yeah, Faisal. But again, I'm not sure. Probably you were asking this question before I answered what I was saying. Um, so printer, and again, printer here is one of those. Okay, it's a generic output device, but then again, it's really a designated printer because we really care about having physical reports. So in this case, I would leave the printer. Okay, if it just says output reports and it's actually something, for example, output reports to the boss, I would actually put over here and say the boss. That's what I really care about the most. Okay, and then I'll figure out, because at this point, the output mechanism itself is not important. I might have given it to him as a something on their phone, or physical, or even by sound. These are all output mechanisms. Okay, but it seems like here that it's a designated printer, just like the printer that we have at the ATM machine is a very designated printer. It produces something very specific and so on and so forth. So we'll leave it as printer. And again, like I said, it is a bit of a gray area, but like I said, the more specific it is, right, and you feel that it is specifically said in the requirements that you want it this way, then we'll put that box in. Okay, if it's something that is generic, even sometimes you hear the word, you see the word interface, even the word sounds very generic. Okay, if you just say the word button, okay, if it's fire missile firing button, yeah, that's very specific. If it's just button on the machine, on the ATM machine, sounds very generic. Okay, now at this point, guys, what we want to do is we want to make sure that we've done things correctly. Okay, are you taking a photo of this? You don't need to, because because it's going to be on YouTube, all of this. You see the videos on YouTube, right?
What's the channel?
It's already on Moodle. I have the YouTube, and all the lectures are all there. Okay. All right. It's at the that link is actually to the playlist, to the entire playlist. You don't need to watch it now, but it's just we're still in the class. All right. So what we do, guys, we do something called, ready for it, a sanity check. Okay, making sure that we're sane. Okay, not sane in the sense that we went crazy, but sanity check in the sense that we're doing things right, that it's a checksum sort of thing. And how we do a sanity check when it comes to system context modeling is that, well, think of it this way. All right, if I have one of these boxes outside and I'm not really getting any input from it, fine. Because I'm receiving output for it, fine. I'm giving output to it, okay. If I'm not really giving it any output, but it's because I'm receiving input from it, fine. Okay, but if I'm not receiving any input and I'm not giving it any output, then why the heck is it there? It's only serving the purpose of confusing the design team. So what we're going to do is we're going to go around the circle doing check by check on each one of these devices and ask, it's got to give me something. It could be input only, could be output only, could be input and output, khairu baraka, okay, even more affirmation. But if it's nothing, then we've got a problem, okay? Type, light sensor, do I get input or output? Okay, input. Thermostat. Okay, food dispenser. Okay, printer. Operator. Heater. Timer. Weight scale. Lights. All right, so we went down the circle. We were able to identify each one of this input and output, so everything is okay. Okay, now you do this sometimes because obviously we got it right before we began the exercise. But had I had, for example, this going on, I wouldn't be able to specify exactly if it's input or output. Or if I put down this, all right, I realize I've got redundancy and I got two things because I'm saying, well, I got the lights or the light intensity, but I already have something already for that. So I'm getting the two inputs The same inputs from, so I'll realize that I got nothing to do with the sun, and then, so I'll realize that it's got no place in my diagram. Okay? All right, guys, so let's move on to the next exercise. No? Okay, the heating system, okay?
Just one question. When you write that down in a piece or a lecture, it doesn't have to be boxes or whatever.
You gotta get a white page like this one.
So we can do it in boxes or circles or whatever, right? Doesn't matter.
It's supposed to be boxes, okay? I know in the lab, they put the external entities as circles, but I keep reminding myself to tell the instructor that it's supposed to be boxes, not circles, but keep forgetting. But it's always boxes, yes, okay? Now, one thing you notice, well, there's a class, the box is actually a class, okay? And the class is representing something. The outside classes were representing external entities. The middle one is representing my system, okay? Now the next exercise is a nasty one, okay? It's really not so obvious, not so easy, horribly written, okay? And it's simulating what you might get in the real world. But also at the same time, if you were able to do this, anything else is a lot easier. Okay, that's the good thing about it. Okay, so we'll do the nastiest one, and I feel like we're gonna have to save the screen at some point because the next lecture we're gonna have to continue because I don't think we'll be able to finish the whole exercise today. All right. So the guys again, the system that we're dealing with is the home heating system. I'll give you a moment to pull it out. It's called the home heating system. Is it?
Just as heating system.
Oh, heating system type. Okay, I'll give you a moment to pull it out. Okay, I already draw a box in the middle. Type. Ready? Type. So consider the home heating system described below. The software controller of a home heating system regulates the temperature in a home by turning the oil-based furnace on and off, provided the master switch is set to heat position. A lot of information that goes into this. Another reason why I like this exercise, and it's a bit nasty, because it actually, this is what they have in cold countries, like say Canada. So these concepts might be more familiar to people who work in, say, for example, in Canada, these cold countries like Sweden or something like that, right? It might not be so familiar to us here, given the heat that we have, okay? But then again, this is what we do as software engineers. We deal with domains that we're not, you're not gonna go to, you get a project for 5 million reals and it deals with, say, football, and you know nothing about football, and you're gonna say, la, I know nothing about football. I'll take the 5 million reals. I'll learn everything that there is to know about football, okay? Myself, for example, as a sport, I know nothing about rugby or curling. Nothing, no idea what the heck is going on over there. But if I got a 5 million real project for it, I'll know everything that is gonna be. Rugby is gonna be my favorite sport, beginning right now. Fine. So guys, what is, and even the guys at home, huh? I'm expecting an answer. What is it, the system that I am building? So home heating system. So let me just put this down on the side over here. So we got home heating system. All right. What about the master switch? Is it the master switch?
Yeah.
The system itself is the master switch?
No,
Oh, we're talking about what's going on inside here, huh?
it's an input.
All right. No, okay. I'm gonna put this down over here. Input. Oh, so not input switch. Master switch. Type. Okay. What is it? A software controller? Because I read the word software controller at the very beginning. Now, obviously, I'm doing all of this to confuse you. All right. So I was doing a lot of hand holding in the first exercise. Now I'm not doing as much. All right. Well, is it the furnace? Do you know what a furnace is?
Yeah. Put in wood.
Okay. Well, that's the old furnace, but now it's they're all oil based. Okay. But now it's basically, it's a big, you can think of a big fat heater that sits in the basement of the house. And then there's pipes that come out of it, and those pipes run through the different rooms. And then as the liquid heat, it could be oil, could be even water. So I think it was a special type of oil. As it runs through the pipes, it radiates the heat. Hence, it's kind of like central heating. Okay, and hence it heats the home. Okay, so we here have in Saudi Arabia at most the fay. Okay, with like we put in one, it's called the space heater, but that's not a space heater. It's a thermal. So the furnace is a big machine, sits at the bottom. You eats up a lot of energy, but you have to, because otherwise you'll freeze to death. Okay. Type. So it's got to be one of those. Which one do you say? 1, 2, 3, or 4? One, home heating system.
I think it's two.
Software control. It's actually a mix of both. It's a software controller who controls the home.
Because when you read the paragraph, it's not saying the software control.
Yeah. But again, because we can't really, I mean, like I said, this is poorly written. Okay. So we have to, this is our job as requirements engineers. Okay. We have to take that input that were given to us written in junk, and then we have to make something out of it. Okay. Now من حبة أوبا. Okay. I'm الفسيخ شربات. I got plenty of those in Egyptian slang if you want. Anyway, where was it? So it's actually a software controller. We're gonna call it the home heating system. هيك عشان ما نزعلش الناس controller. Okay, but that's what it is. It's not the entire heating system. It's just the controller of that system. Okay. As a matter of fact, the word controller plays a big role because it's not really the entire thing. It's controlling the heat. Okay. It's kind of like the cruise control system. Okay. In the car, it's not really dealing. It's just controlling the cruising. It's not actually doing the cruising. Type. All right. Are we done? Do we move to the next?
Yeah.
No.
No.
No, not yet. We're still on the first line.
We have
Got a couple of things missing here.
the regulator.
Yeah, the
The
oil-based
furnace.
Furnace. Okay, so we got the furnace.
That's the output.
And you also need the regulator.
All right, like Faisal said, a master switch. She was saying something.
You know
A
what's-
regulator. Well, Finkim is regulated. Well, the regular. See again. Here's a scope thing, huh? So the thing is itself is what's regulating. Okay.
The system is what regulates them.
Exactly.
So the system sends signals to the furnace and
We will be getting a lot of inputs, kind of like what we did with the aquarium. Okay. So the system's in the middle, grabbing input, deciding on certain outputs with it to make sure that everything is on level. Okay. So literally what the cruise control system does, it grabs input about the speed, different inputs, figures out what the speed is. So you set the cruise control to 100, it drops the speed to 99. So it says push a little bit more gas, goes up to 100. 1 second later, it grabs the speed, looks at it, it's 101. Ah, too much. Ease off the gas a little bit. Okay. It itself is not pushing, it itself is not the gas or the brakes or anything like that, or the engine or anything like that. Okay. Thermostat. Naif. Where did we read thermostat? Or you're ahead of us, huh? Okay. No, that's fine. You don't need to apologize for anything. I just didn't know if we got to that level. Type. The furnace heats the water. أحط هنا water on the side. Think about it later, huh? Just keep it in your mind.
That's the furnace.
Which then circulates through the house. Okay, we put down here another noun, house. The controller activates the furnace whenever the home temperature T falls below DT. DT is desired temperature -2, where DT is a desired temperature set by the user. Okay. The details of the furnace activation procedure is as follows. The owner sets the master switch to heat. خلاص, we got that. The system detects that the home temperature is below DT -2. The system then outputs a start command to the motor.
So a thermostat. Right?
Right.
Yes, we use something.
So a thermostat that talks to the furnace.
Okay. So yes, exactly. So why is it that we decided on a thermostat? Exactly. So Naif was able to يتنبأ, and he did a very good job. Okay. This is a poorly written piece. It didn't say the word thermostat explicitly, but again, this is our job to realize, well, how the heck are you going to get that temperature from? So we're missing something. Okay. So pasted in the wrong word. Where okay, what else am I missing here from that line? We reached up to step number 3. We're missing something. The motor, yes, exactly. نايف متألق this exercise. Okay, so we got the motor. طيب. What about the user?
The master switch.
Okay, so the user really gave nothing but the master switch so far. But obviously the desired temperature, which we're gonna get to that in a moment. Okay, let's leave the user for now again. The house itself. Are we interacting with the house itself? No. So we'll take that out. What about the water?
Yeah. Because
Are we interacting with the water? Or are we receiving input from the water?
The furnace is interacting with the water.
The furnace is interacting with the water, right? We're not actually getting any input from the water, and we're not actually given any output to the water. So I'll take out the water.
isn't it like the light that was like
But the light was-
Yeah. It's not. I mean, water is like the sun when it comes to the aquarium. Okay, but from an output perspective, not from an input perspective. Okay, or the food, which was actually something outside the output and was outside the input as well. Okay, but there's something I think I was missing. I forgot what it was. I answered the question and forgot. يلا الله خير خير. I can't remember what it was. Oh yeah, pipes. Somebody said pipes. Okay. Now basically a furnace is something like this, and there's pipes that come out of it from the sides.
So it's all included in the word.
Okay, again, here's my little software system. It's interacting with the furnace. Is it really interacting with the pipe? And here's the water.
No, it's just-
It's not really interacting with the pipe. So again, I'll leave pipes out of it for now. Okay. Type. Step number 4. The system monitors the motor speed, and once the speed has reached the normal operating speed, it outputs an ignite command to the ignition actuator, like a spark plug. Okay, bougihat, I think that's what you call it in Saudi Arabia, bougihat, right?
Oh,
I don't know. And an open command is sent to the oil valve. So much is happening here. It's like a feast. Yalla bina.
The speed monitor.
The speed monitor.
that interacts with the pipe.
Okay, so let me put down speed monitor here. It's kind of like the naughty list. Okay. Is it really having a speed monitor? Or is the motor itself telling us its speed?
Because they said that once it reaches a specific speed,
Yeah.
we will have another app.
Yeah, but, well, I know, but I'm asking. Are we getting the speed
Oh, no, we're
reading
getting
from
the
the
speed.
motor itself,
Yeah.
or some sort of a speed monitor?
The motor itself.
Okay. No, the motor itself is nothing but an engine. It just says push and it just pushes. Okay. So it's a different thing that gets the speed. Okay, now in cars, what they do is to understand the speed. Okay, there's a little clicker on the side of the wheel. Okay, and every time the wheel rotates, it clicks it, a full click. Okay, or the axe. Okay, it makes a full click, and then it sees how much time did it take to make the second click, and with it, it figures out the speed. But it's definitely not the engine that starts pushing. So we know. So that's a good job. I think who said speed monitor? Luna,
Yeah,
Luna? Is that your name?
Done.
Dana. Okay, so good job. Let me take that. It's one of the features that I rarely use, but it's a pretty cool feature. Just go like this. 2021. Yeah, that was teaching that exercise was completely different 2009 when I first began. But what else is missing? Ignition actuator, Naive, good job. Ignition. Naive, can I actually ask you a question? Is the ignition command, the ignite command, the input, well, so the device, well, the ignition actuator? Naif? Well, the answer, I'm not sure what Naif went, but the answer is it's the ignition actuator, because the ignition command is nothing but a command. What else is missing? All right, got the oil valve, right? And we give it open command. صح? All right, to the oil valve. Just this little valve, and just say open to release some oil, and it's what really heats the water actually. Okay. The system monitors the water temperature. خلاص, we're back again to the thermostat. And once the temperature has reached the predefined value, it outputs an open command to the circulation valve as well. So we heat up for the oil inside to make it heat. But then as it reaches the heat that we want, the level, then we go ahead, circulate through something called the circulation valve. So what is it that we're missing here? Circulation valve. Yes? I like the way you think. We're gonna get to that. But I like the way you think. All right. I was leaving it to the end of the year. Anyway. So Ranim says a timer. Are we missing a timer here? Okay, system monitors. Okay, so we're getting, but then with a thermostat, how is it that I know to go ahead and read from the thermostat other than using a timer? But it actually gets a little bit more clear a moment, and in step number 6, you can actually read the word 5 seconds, and we're gonna get to that in a second. But it's true, with just what we already have, as Ranim said, we already have a case to have a timer. Timer shows up in so many systems. Okay, that's the way it is in the world. Okay, now number 6, the last step, we have to get out of here. The once the home temperature reaches DT plus 2, the system deactivates the furnace by first outputting a close command to the oil valve. We already have that after 5 seconds. So how do I figure out 5 seconds? I have to have the timer again. Outputting a stop command to the fan motor. Because we have motors, صح? We have motors, so right over here. Is the fan motor different than, okay, Dalal, I like the way you think. Just wait for me on a second here. We're getting ahead of ourselves, but the fan motor, is it different from the motor? Okay. Well, if you read carefully, again, this is because it's poorly written requirements. In step number 3, it said send the start command to the motor, right? So, but it's probably the same motor. Now, obviously, I would want to make sure I got this right. This is requirements validation. Okay, remember requirements validation, that step? Okay, but it's probably from the logic. We opened up to activate the motor when we wanted the heat, and now we're stopping it when we want it. So the fan motor is what we refer to as the motor, but now we want to be more explicit here. We're going to say down fan motor. Okay, and a closed command to the circulation valve. We already have the circulation valve. Okay, now still I'm missing something. Where the heck did we get the DT to?
Isn't that
The
thermostat?
user.
The user. Okay, so the user then gives us an input type. I know you're all boiling for the same answer to the same question. Okay, Vernus would have. Okay, let's do a sanity check here. Huh? Let's do a sanity check. Okay, I'll begin with this master switch. Okay, so guys at home, ready for a sanity check? Okay, master switch. Am I getting input or output?
Input.
User. Speed monitor. No, speed monitor. I'm reading the speed. So I'm getting input from the speed. Okay, so I ask the motor to run, and then I check if it's running at the right speed. So I get input back again saying you're running at the right speed. Okay. No, it's not. Okay, so like I said, the engine in the car runs. I'm giving it output, I'm giving it gas to go ahead and run. But then I want to check how fast is it running. Then I check the speed, and then it tells me back in my odometer, which you see in front of you in the car. That's you're receiving input from the motor or the actual speed monitors to make sure how fast you're going. Okay, so it'll be input as well. Okay, timer. Okay, that's usually obvious because we can never actually give output to a timer unless we're asked it to time something. Ignition actuator.
Output.
Sheikh, haram alayki.
Uh,
Yeah, we're sending it. Let's read it again, huh?
yeah, we're
Okay, we
sending
send it. It outputs an input command to the ignition actuator.
Yeah.
Okay, oil valve. What do you think, guys? Noha,
Remove that.
Anim, huh? Oil valve
Remove that.
is what?
Remove that completely.
Why? We're giving it an output command, right? Sah. It says so clearly. An open command to the oil valve. It has a very strong case of staying. Okay. Circulation valve. Okay, sah, guys. So even guys at home, I like that you're following me on this. Motor fan
Well,
or fan motor, actually, motor fan. Yes, very good. I'm giving it a command to run. Thermostat. Input. Furnace.
output.
Output was the input, and if it is, what input am I getting? And what output am I getting? Okay, so this is why you can notice I've left it to the end. Okay, so you're gonna say, well, through the furnace, I get an output command, I give an output command to the oil valve. Because we already have the oil valve. There was an output command to the ignition actuator. Well, I get it already. We have something from the timer. Okay, I got it already. The speed monitor. I got it already. Fan motor. I got it already. So really what's going on is that all of these little devices are inside furnace. Okay. Now, technically, I could have just erased all of this and I put down furnace, but is that helping me? Okay. When I write code here in the home heating system controller, I need to know the specific things that I'm going to be dealing with. Okay. So in this case, the abstraction of the containment of the furnace is not really helping me. What I really care about with my code over here is that I'm going to be getting inputs and outputs from these little things, and I'm going to write code now that I know I'm going to be dealing with those specific devices inside. Okay, then I can write my code accordingly. Okay, I can actually make a proper design. If I just keep saying furnace, so think about another extreme example. Okay, an airplane. It has so many things inside of it. Okay, the flaps, the wings, the motor, the lights, the wheels. If I just make one big box and say airplane, how is that helping me? All right, so it's not really helping me. So I look at this furnace and I realize it fails my sanity check.
You already have all.
And because I had all of its internal components, which is actually more helpful to me to write rather than just having the furnace, and I'll be done. Okay, so that would be the answer to the second exercise. And again, that'll be on YouTube. You don't need to take pictures, but it's okay. You can take pictures if you want. All right, maybe for ease of access, I suppose. Yeah. All
So I
right.
started with the
Okay. All right. So I guess we could be ready now for a quiz on a quiz lecture on Monday. I'll see. I have to see if the proctors are available though. Okay. And I also have to see a time where we all agree on, because if we can't actually have it inside the regular classroom time, we get after us because there's two sections and there's some who have conflicts with this lecture over here. Okay. All right. So that's it for today. I'll see you inshallah next week. Have a good day.
I think next Monday we have a course,
With
another course.
okay. Well, what course is that?